This question is asking us to find the slope b sub 1, and I think it's a linear regression equation. So look, you could do this in StatCrunch. I think if I click it right now, it's not going to work for me because I have a student's question opened up. It's probably quicker to do this in Excel or Google Sheets, okay? Because in Excel or Google Sheets, you just have to type in a couple quick commands and it pops right up. I guess I'm not 100% sure which one's quickest, but look, if you click this in the top right corner, you can copy it to clipboard. And then there's obviously a way to copy to StatCrunch, but we copy that to clipboard, and then I'm going to type in Google Sheets and Google search because I never remember the address. Could do the same exact thing I'm about to do in Excel. It'll get you the same answer. Okay, there it is, and they want to know the slope. And I guess the one big thing that students get wrong is that the slope calculation, it has to have the correct y and x variables plugged in the right order. Okay, so we need to calculate a slope of a linear regression line. I'm just gonna give it a label there, and all I have to do is type in equals slope, open a parentheses, and click and drag the y variable first. So we're expecting that the dollars in sales is driven by the x variable over here, by the number of sales. That's why I put sales first, sales in thousands of dollars first, and then the number of sales second. So I got 0.9768, and that's what StatCrunch got, 0.9768 rounded to the third decimal place. And what does the slope mean? The slope tells you how much the y variable is changing for one increase in the x variable. So remember, the x variable is number of sales, y variable is the thousands of dollars in sales. So this tells us that we go up by $977 when you round to the third decimal place. $977 increase in sales for every one increase in sale to a customer that we make. So you sell to another customer, we expect the total sales to go up $977. So that's what that means. This answer here, when zero salespeople are working, that's the y-intercept. That's the other part of the least squares regression equation. So when x is 0, the y value is the y-intercept, which is the b sub 0. And actually, that's what they're asking us to find here, b sub 0. So to find the y-intercept, which is b sub 0, you just need to do the same thing, except type in intercept. And click and drag the y variable first, comma, click and drag the x variable. 0.7638 is what I got, which is what they got, okay? And remember what b sub 0 means. B sub 0 tells you the y variable you expect when x is 0. In other words, the y-intercept is going to tell us the amount of sales we expect when the number of sales is 0, which, it's never going to happen. We're not going to get any money in revenue if there's 0 sales. Oh, this is salespeople. Sorry. This is the number of salespeople working. So the y-intercept is telling us how much money we're bringing in sales when x is 0, when there's 0 salespeople working. It's in thousands too, right? So 7,000. What? That can't be that high, right? Yeah, I guess that's it. $7,638 in sales is expected when 0 salespeople are working. Is it meaningful? There's no x equals 0 value. I don't know. It depends if it's meaningful. Can you sell anything if nobody's working? I'm going to guess this one, but this is kind of debatable. Because like a store can have like an automatic checkout, I guess, but I guess it doesn't make sense because you need to talk to a salesperson in order to get these items, whatever they're talking about here. So I'm going to go with that one. And okay, that's lucky guess. If it's Walmart, you can still make sales even though if there's no salespeople because they got that automatic checkout thing. Okay, and then this part, they want you to plug in the values into the regression equation. Look, the slope is always attached to your x variable. So I'm going to put my answer for the slope, 0.977 here. Then the y-intercept's always hanging out by itself. That should be the equation. Uh-oh. What did I do wrong? Sales from number of salespeople working. What do we get for a slope for salespeople working? 0.977. 3 decimal places, so I did that. What was it, negative? No? 0.977 is the slope. So that is in the correct spot. The y-intercept is 7.638. Oh, 7.638. Sorry, I didn't put my decimal. If 17 people are working, what sales do you predict? All you have to do for this is to plug in 17 in here and then solve the equation. So replace 17 with salespeople working. So I'm going to do 17 times 0.977. Add that result to 7.638. 24.247. Round to the nearest dollar, so it rounds down to $24. Oh, what did I do wrong now? Round to the nearest dollars. 17 people are working. What sales? No, we plug in 17 here. Maybe I typed something in wrong. 17 times 0.977 plus 7.638. I don't get it. 17 people working, so you plug in 17 there. Add that to 7.638. And if we round to the nearest dollar, that's $24. So maybe they want 24.25? Oh, it's in thousands of dollars. I didn't read. Okay. Yeah, so I forgot that our units are in thousands of dollars, right? So when you plug in 17 workers times 0.977 plus 7.638, that's 24. That's not $24. I don't know why I just stopped there. That's $24,000. That's $24,247. Forgot about those units. And if sales are actually $25,000, what is the value of the residual? The residual is telling you how far off your prediction is. Okay, so we predicted it was going to be $24,247. The actual sales was $25,000 when they brought that many people on the floor. So the residual is just subtracting the two, but the sign is important. Okay, it's a difference of 753. So the residual is going to be found by taking the observed value subtracted by the expected value, 753. Okay. And that order is important because you have negative and positive. It'll be wrong either with the wrong sign if you don't do it in that order. The tradition for the residual is you take the observed value subtracted by the expected value. Have sales been overestimated or underestimated? We predicted 25,000. That's right. No, we predicted 24,247. That's what our model predicted. The actual value was higher, so we underestimated based on that data point.